a little earlier, I sent around a URL. I'm not sure if everybody saw it. That's this repository, and all the stuff I'll be using is in this repository. The files that are actually interesting if you want to set up your own Hydra server are those Hydra master and Hydra slave. The Hydra master is essentially a configuration.nix file that configures Hydra, and the slave configures a build slave for Hydra. And then these other files are mostly examples, and this Hydra network file is for NixOS that instantiates this whole stuff. So one thing I'd like to do is to create a couple of virtual machines on this laptop and actually have them start up and build something to show how that's done. Okay, I'm going to use NixOS to do this. So in NixOS, it's really simple to take these configuration.nix files and instantiate machines that are configured this way. And that's what I'd like to do. And the important bit for NixOS is that the machines it creates live on the release 15.09 branch. And this machine is running, and other machines are probably also running unstable or master or whatever kind of release. And there is a bit of a dance that we have to do to configure these machines so that they cope with the other release branch. Okay, where do I start? Let's start up the cluster, and then while it builds, then I can show you the Nix files that we can see how these look like. So the first thing I have to do is tell Nix that I want to work in the release branch. And then NixOS compiles the whole machine configuration local on your machine and then copies it to the server where you want to run this stuff, which means that your machine needs to know about the binary cache for the release branch. And if your machine is running this NixOS release version, you don't have to do anything, you're fine. If you don't run that particular release branch, then you have to subscribe to the channel, update from the channel so that your machine knows the binary cache for that channel. This does not mean that your machine will change in any way, right? You're just adding information about the cache. And then we have something like this. So, and this means that I use Nix packages, which corresponds to the current version of the release branch. We just download that live from GitHub. So whatever is the current version of the channel we use here. And then this bit tells the Nix daemon that where to find all the information about the binary caches so that we don't download more than necessary. And now setting up a Hydra is essentially a matter of creating a network. And if we are lucky,
if deploy doesn't, if it's only one,
it's two machines. It's one master and one build slave.
So it deploys everything.
Exactly. So the network, this is our network.
I mean, if there is only one network, the only NixOS deploy will just deploy it.
Yeah, exactly. I don't have to give the name because there is just one. It will use the default one. So, and this is these are the instructions for NixOS, and obviously we could add a whole bunch of build slaves here and start up a complete distributed network. But since these machines run as virtual machines in VirtualBox locally on this laptop, I found that having two is already a bit of a challenge because the machine doesn't have so much memory. And I already forgot something. One thing, the Hydra server communicates with the Hydra build slaves via SSH. And so you need to generate an SSH key that's used specifically for the Hydra server to log into the Hydra slaves. And that's not included in the repository, obviously. So this has to be generated with that command here. And now that it's there, the deployment should also work. Okay, maybe I'll show you what the configuration looks like while this stuff is working in the background. So the first thing is I'm I define a basic machine, and this is included in those two other cases. This is stuff you shouldn't have to worry about. If you have a machine, then it's configured already, right? But there is very simple stuff. I use VirtualBox as a target. The locale, I don't know, it's probably not important, but I'm kind of used to defining it just to be sure. Then this is actually very important. If you have a Hydra, then you should be running change-rooted builds. Then you should use isolating the build from the rest of the system. If you have a very large server and there are lots and lots of jobs running, then it can actually happen that you run out of build users. By default, you have 10. So for most machines, that's going to be fine. But if you have a machine that runs 20 jobs in parallel, then obviously you need at least 20 build users. And I typically use slightly more so that people working interactively on the machine can also build stuff in parallel.
This creates users as well?
Exactly. So this tells you how many build users do you want to have created by NixOS. Then this stuff here is just to keep the machines a little bit smaller, to disable some things that we don't need. We don't need NTP running in a virtually hosted machine and this kind of stuff. And finally, I want to control the users that live on that machine entirely here. There is no interactive user management on those machines, and here I just add my public key for that user so that I can actually log in. Okay, deployment has actually worked. This is good news. So based on this configuration is then extended upon in the build slave configuration like this. So build slaves are really, really simple, and basically the only thing that you really want or really need is this entry, where I tell the SSH daemon to accept logins with this public key, with this build farm public key that we generated a minute ago, and then I force the command that's supposed to run when those logins occur to nixstore serve write, which is what Hydra needs to have builds executed remotely. This is the only thing Hydra is ever going to execute. So that key it's not supposed to give you an interactive session because Hydra doesn't need it, right?
So this is somehow different from the Nix build slaves? Or?
That's exactly the same thing, actually. This is I configure distributed builds in Nix, and then Hydra takes advantage of that. It's the exact same mechanism. What I also find I've discovered the hard way is that this little thing here actually is very, very useful, because those remote builds don't honor the niceness setting that you configure for your local Nix daemon. So when your Nix daemon is configured to run builds with nice, then these builds won't. That's why I force it here. So that builds that I run interactively on a machine take precedence over ones that get scheduled remotely. So this is a build slave. This is basically the only thing it needs. And another thing that it needs is this automatic garbage collection, because if you build a non-trivial amount of packages, then you'll use disk space like crazy, really. And this thing runs once a day the garbage collector, and then there is this bit of shell code that essentially figures out how many bytes have to be garbage collected so that 32 gigabytes are free. And then it garbage collects just so much, right? So every day at 5:15, all my machines have 32 gigabytes of free disk space. And this value obviously may vary a lot, depending on my machines. My build machine is not that fast, so it actually doesn't compile hundreds of gigabytes of packages in a day. But if you have sufficiently many build slaves, you might, right? Finally, the Hydra server, the master, and this is more interesting, because one problem that we have with Hydra is that for some reason it's not part of Nix packages. So we have no NixOS module for it, and we have no build instructions for it. And instead, this stuff lives in this separate repository. And now the question is, how do you integrate this into your setup? And the easiest way I found is this. I basically fetch that tarball directly from the Git repository and import it here into my module system. So basically, I say whatever the code is on GitHub, I'll just run that. This is probably a very bad idea. The mechanism is fine, but instead of following master unconditionally here, you should probably use a specific Git commit ID, right? You should say, I follow this particular version, and then if you decide to update, then you update the hash. But for the example, I just say, let's take the latest one. So every time you recompile your configuration, you'll get the latest version of Hydra. Updating Hydra is usually safe. So in 2 years or so that I've been running Hydra, I have had maybe only 1 or 2 cases where an update caused problems and then they were easy to fix. But if you upgrade Hydra, then Hydra may convert the database scheme of your local database, and there is no way to undo that. So once you've upgraded to the latest version, and if that update changes the database, then there is no way to go back. You can change the hash to an older version, but it won't work. So, okay, for the server, we import this module, which is the NixOS module that Hydra ships, and we customize that a little bit further down. Then the Hydra server, technically Hydra is portable. In theory, you can run Hydra on anything. It's mostly Perl code. But de facto, it's only tested on Linux, and it's actually only tested on 64-bit Linux, which is why I put this assertion in here. But in theory, you can run the Hydra server on whatever you want. It's just that it might not work, and nobody's going to help you figure out why.
Singleton thing?
A singleton is just a fancy way of defining a list with one entry. So this is the same thing as this.
Okay.
Right? Because I can state any number of assertions, but since I have only one, I use this singleton thing.
It's like a 5-character function.
Yeah. Okay, then this stuff is a highly insecure way of getting this SSH key onto the server. So I take the SSH key from the local directory and then copy it into the target machine so that it has the key. But obviously this means that this key also lives in the Nix store, which means that it's world readable. So every user on that machine has access to that key. So you shouldn't do this. I do it in this configuration only so that this configuration runs completely automatically, right? I run NixOS deploy and it works. But if you set up your own Hydra, then please copy the key manually. Don't deploy it through this mechanism. I think there is even some smart NixOps function of deploying keys, but I don't really know about it, how that works.
Resources.
Yeah, there is a way to do it, right? But I just don't know how it works. Okay, allow TCP ports is obviously important, that you can access the web front end. The distributed builds are here. Obviously, you can configure any number of hosts, right? If you have a sufficiently powerful machine, you can define 10 build slaves and add these entries here, and this can probably be made even nicer and shorter, and that you just configure how many build slaves you want, and then it works, right? And obviously, you can also add other machines in here that you are not deploying as part of this configuration, but that real hardware that you own or whatever. This option is also very, very, very nice on the server, and it's also very nice on the build slaves, although it's really important on the server, because when you have a server where people download binaries from, you want to garbage collect as little as possible. Obviously, because whenever you garbage collect something, it means that someone else can't download it anymore and may have to build it themselves. And so this auto-optimize will hard link actually. It will hard link all files that already exist in the store to each other, and it saves tremendous amounts of space. So on my server, it's I don't know, when I didn't have that enabled, every now and then I ran this Nix store optimize command manually, and it frees up like 50% of disk space or so. It's really a lot. On the server, by the way, something I discovered today is that it's a really good idea to use an advanced file system on the server, because if you use something like X3, for instance, you'll fairly quickly run out of the hard link counter, is basically will run over. So this is the actual Hydra configuration. Enable, obviously, your public URL, your public email address when Hydra sends notification emails, what's supposed to be the sender. The port, if you want to use a port that's in the privileged area below 1024, then that's not going to work out of the box because the Hydra server does not run as super user. So if you want to do this, then you have to somehow figure out some systemd magic to start it with appropriate privileges or something. It's what I do is that I let it run on port 8080 and then have a reverse proxy in front of it, or use IP tables to forward packets from port 80 to it, something like this, right? But it's easier to let the server run on a non-privileged port so that it doesn't need super user privileges. Then there is one more key that is important. Bye. There is one more key that's important. Hydra signs all its build products. And to sign this, obviously, you need a public key pair. And this is also, I'll show you how this is generated in a minute, but this is also a key that you have to generate and copy onto the machine to make it available to Hydra. If you don't have it, then the packages won't be signed. This is easy to test. We can do it in a minute. But but these packages should be signed, obviously, so that people who use your server know that they are getting things that are actually from your server and not from someone else. For Postgres, technically you don't need to worry about Postgres. Hydra will configure it for you. The only option that I've found nice is that I add the version number of Postgres to that database directory on the disk. So when I run Postgres 9.4, which is the default right now, then the state will live in Postgres 9.4. And when I upgrade to a new version, then it will have a new directory and it won't screw up my old one, right? So this is just to have kind of the ability to go back to an older version without having everything destroyed in the upgrade process. This is
the same thing and the version number of Hydra. And then
you could put that in there too, yeah, but then you have to worry, yeah, sure, but then you'd have to worry about copying it when you update Hydra, but you could, that's true, absolutely, yeah. Okay, and finally, this job, this is something that should not really exist. This is just a thing that automates something that you would normally have to do once after you've created the machine. So this is manual stuff that you have to run. And this is just a job that runs it once after you create the machine. So the first thing is that you need to create a super user. In this case, it's called Alice. And the reason why this is a bad idea is because the password is written in here, right? So obviously you should log into the machine, run that command, enter your secure password. But for sake of convenience, I run it as part of the boot process here in this example. Then the signing keys need to be created. There is a command for that, this generate binary cache key. That generates the keys, puts the appropriate permissions on it, creates this file so that the next time this job runs, we don't do it all over again, and that's it. So this is not something you should have in your configuration, but you should obviously run those commands manually in a shell. It's just convenient to deploy this way. And the last bit, the Hydra, the NixOS module for Hydra defines a user called Hydra, and we have user IDs for allocated for that user, but for some reason the NixOS module from Hydra doesn't use them. So I add this to make sure that when you create a Hydra user, then they will always have the same user ID and group ID, namely the one that we reserve in NixOS. I think it's 122. If you don't do that, then the Hydra server will have some random ID. I'm not sure why they don't put this in the upstream configuration. I don't know, maybe because it was added in a later version of Nix packages and they want to be compatible to earlier ones or something. I don't know. Okay, so these are the configurations, and finally the network that ties this stuff together for deploying with NixOps. And so, if I'm not mistaken, we should have a running Hydra now. So this is the IP address of Hydra. let's see. There's our server. Oh, that screen is too small. So these are our Hydra servers. Okay, we have a super user called Alice with password foobar. No, you don't have to remember. And now we can do stuff. Build jobs on Hydra are grouped into projects. For a build job, it actually doesn't mean much into which projects you do it. So I think that normally, looking back, I should have probably had one project called Nix packages and then put everything in there. But in the beginning, I started a project, and here on the server that I configured, I started a project for everything. And then when you look inside of these projects, then there is exactly one build job, and it's always called master. So this is the thing that actually configures what to build, and this project is just a namespace. I'm not sure whether it's important. So for the purpose,
there is how you do it. It's based on releases.
I guess, yeah.
Releases, so one project can be released. So basically, you can create a channel out of it.
Oh, okay.
That's how I got it from.
So. Okay, there's our project. And now, to have it build something, actually, we create a job set. Even though there's one thing I'm not supposed to forget, because there is this command. Because our Hydra server is going to build stuff from this release channel, and so it should know the binary cache for this channel, so that it doesn't start compiling GCC from scratch. That would be bad in a virtual machine.
So you also have to run this in a cron job. I mean, that is the auto upgrade.
Yeah. So. So this is our Hydra server, and let's define a build job and see what happens. I have the easiest one is the Nix packages. So let's just run it. Okay, the check interval says how often will the Hydra evaluator try to evaluate this job set and see if there are new builds. I think that it doesn't check it any more often than once a minute, so everything below 60 seconds makes no sense. But you could, in theory, say, I don't know, I want this job set checked once an hour, once a day, whatever. Depends on your policy, but 60 seconds is, I think, the smallest you can do. If you disable polling, which is pretty much equivalent to this one-shot job type, that means that Hydra never runs this job set automatically, and that you, as an administrator, have in the web front end push on evaluate this, and then builds will be run. This is also kind of nice for checking, for instance, pull requests. So I create a job for some pull request, but I don't want the guy who created the pull request to be able to trigger any number of builds every time he pushes. And so I create this one-shot build and then let everything compile, and then when he says, yeah, I fixed the errors, then I'll start the next one, so that I control how many builds run because of this remote code. Scheduling shares. The scheduling shares work like this. The number that you enter here, these numbers will be added for all jobs that you defined, and then every job has a percentage of the available shares. In this case, we have only one job and it has 100% of the available shares. If we create a second job set and give it also 100 shares, then both have 50% of the available shares, obviously. What this means is that a job can run for 50% of the day without being interrupted, in this case. Okay, so if a job has 50% of the shares and it has 100,000 builds in the queue, then Hydra will schedule all the jobs from only this job set for half a day, and then it will start scheduling the queues, the builds from the other job set.
So it goes job.
There is some job who owns the queue for this moment in time, and then only builds from this job set will be scheduled until his allotted percentage of the build time runs out, right? And this is determined by this shares value that you have here.
It's always per day.
Yeah. Okay. So basically you can put any number in here, right? It doesn't matter. I always take 100, and then when some job is less important than others, I give it 50 or something like that. But it's hard to predict what it exactly means. This email notification is something that's very popular. People set email notification, and when a build fails, then you have this meta maintainer field in the build expression, and then this person gets an email, which means that I regularly get emails from Hydra servers somewhere in Italy and whatnot, right, and tell me that, yeah, this build doesn't work anymore. And then when you try to respond and tell them, please click on this button and switch off the email notifications, then you can't reach them because they haven't configured a proper return address, and it's yeah, so email notifications should be off unless you know exactly what you're doing. Or if you want to, then you can direct them to whatever address here, and then you can make sure that this then ignores the settings in the builds.
So
you can override
but you don't need to check it, or you have to check
yeah,
it.
now they have to check it, right? And then
it will get
but I don't want it to send emails to that address either, so I'm not going to check it.
Yeah, sure.
And then the number of evaluations to keep, that is basically a question of how much disk space you have. When you say you keep the latest evaluation, it means that whatever is the current head of your Git repository, those builds will be kept, and everything else may be garbage collected when the disk is too full. And so when you have a project where you say it's important that our developers can go back in time for at least, I don't know, a week or so, then you would probably keep the last 100 evaluations. Or if you say, I build only what is the latest and greatest, and that's what people are supposed to download, then you can set it to 1. Or if you say, I run those builds only to see whether they work or not, and the binary packages are actually a nice side effect, but that's not what I really care about, then you can set it to 0, which is what I do most of the time, actually. So if the builds are there, they are there. But it may happen that the build is run and then it's garbage collected half an hour later and it's gone again. What I care about is the build log. I care about the information whether it succeeded or not. Okay, and then if we look at this build expression, there are two things that we need to define as external input for this. First of all, we have to give it the Git repository where this description of this job set lives. So when I change the job set, obviously the Git repository will change and Hydra will start re-evaluating things. Yeah, they're right. And then since this is going to run builds from Nix packages, we also need, okay, and I use here this channels repository, which means that we only take expressions where we are 100% sure that there are binary packages for that available from the cache server, so we don't start building GCC or anything like that.
But in your job, there is no Nix packages as input.
No, it's not. It's
so Nix packages is like a magic?
It's the same thing that the Nix path does. So when you use this magic syntax with those brackets, when you refer to something like this,
So it
then
sends
this,
it to Nix
right, then
package.
this must either be an option, an argument to the function, that works, or if it's not, then in either case it must be defined here as an input. And then this magic name will be there, right? And then you can set clause to, I don't know, what do we have? Checkouts, privacy, right? You can string values, and then you can customize the builds, right? That you have one expression, but you pass a parameter in there to select a different version maybe, or I don't know, right? You can do many fancy things with this.
This Nix package's definition, I think it needs to be compatible somehow with the Nix that runs on the Hydra machine.
No. Yeah, well, okay, Nix has to be able to interpret it, obviously.
Because I'm running the Hydra on version 14.12 or something.
Yeah, a very old one.
I can't use any more than newer
Yeah.
channels.
Yeah, it's true. I mean, they added a couple of new magic built-ins and keywords to Nix, and if your Nix packages use those, then your Nix version must be able to interpret them. Yeah, that's true. Okay, so in theory, I should be able to say create job set, and then this should actually build.
5 minutes. No.
It's going to take a while, yeah. But see, it's already starting. Who would have thought? So now it's checked out the Hydra tutorial repository where this expression is. Then it's checking out the Nix packages repository, which is going to take a while longer. Then it will evaluate the thing, decide which builds needs to be run, and then run them. So meanwhile, what does a job set look like? A job set is essentially just a dictionary where you define the name of whatever build you want to perform, and then on the other hand side you have a derivation that you want to build. So the easiest thing you can do is you just define from Nix packages. This is I hard code the platform here. There is this hello world package which is in Nix packages, and we say okay, let's build that, and then we define this hello world 1 and say this build runs hello world in Nix packages with Linux 64-bit. And then obviously you can add other platforms here and have other jobs for those. Then there is a little helper function, this Hydra jobs function, and the purpose of that is that it removes everything from the expression that Hydra doesn't care about. So if this expression defines all kinds of pass-through attributes and I don't know what, right? Then this stuff takes a lot of memory and it takes time to evaluate, and then this Hydra job function removes all that and makes the package a little bit smaller. It saves time, right? And then finally, this is a use case that's very, very common. Here you generate builds, and this gen address function, and you pass that a list of platforms for which you want builds to be performed. And the argument to that is a function that gives you a derivation for that particular system. So there is this, maybe I should make clear where this stuff comes from. This packages for is defined in this release Nix, release lib Nix file up there. So this is basically the Nix packages package set for this particular architecture. And then the result of that is going to be an attribute called hello world 3.64-bit Linux, 32-bit Linux, 64-bit Darwin, right? Whatever kind of stuff you add in here. Builds have succeeded.
Is it building it on
There it
slave?
is. It's done. So and here you have, so here you can see how that matches up. We have this hello world 3, and hello world 3 here has this platform for which it has been built automatically attached to the name. So now suppose we want to run that build on more than one platform, which we can, then we just uncomment this, right? And now this thing should generate two attributes, one for the 32-bit build and one for the 64-bit build. And now hopefully Hydra should pick that up and add those builds for the other Linux. If you schedule builds for a platform that the server, I should maybe show you here, Hydra master. So here we have this distributed builds configuration, and for every machine here we say what kind of system this is, and this is the system that determines which systems it can build, right? So if I want to run Darwin builds, and then I just have to configure a build slave that happens to have this system string for Darwin or FreeBSD or whatever system you want to support. So if Hydra can't compile this itself, but if you have a build slave in that architecture, then it knows where to distribute the build to. And unless I'm mistaken, we should have...
So now all the 32 bits should get built
Bam.
on master.
Master would have built them, but in this case we are cheating because we are just downloading them, right? Because we get all the binaries from NixOS.org. So now you see this +2, right? 2 new jobs. Here you see which ones. These are the 32-bit builds. They all succeeded curiously enough, and then we have this nice page where you can see exactly what jobs succeeded and yeah. And obviously the easiest way to define this is this. So this line does pretty much exactly what the stuff up there does, right? It's just that this map test on function is a funky helper function that expands to this kind of stuff you see up here, right? Exactly. So this hello, those two builds, they come from this line.
Just one question. How does it know? How does it know to build the hello package?
Because
I mean, it looks like a function without the net test on function.
Yeah. Okay. The name that you choose here has to be a name that coincides with a package, Nix packages. So if I add something like...
This is only useful for Nix packages.
Yeah, exactly. So this thing would give you an evaluation error actually.
Okay.
But since there is a hello package, you get this result. So here, that basically this shows you how this stuff evaluates, right? This is what you actually write. This is what that shortcut expands to, and then this thing again expands to something that's an explicit attribute like that one, right? So that's how this stuff evolves. And then when you know that, at that point you can easily read the Nix packages top level release.nix. Where is it? So and here, this is the thing that Hydra NixOS.org builds, right? So here's just a list of packages, and then it specifies for which platforms these ought to be built. There is another very nice combinator which can be useful, and that is this one. What this function does is you give this function a package set, something like Nix packages or a subset of Nix packages, and then it goes recursively through this package set and looks for every build at the meta.hydra platforms argument. And if this attribute contains a platform that you support on your server, then it will automatically schedule a build for this. So if you want to compile all Haskell packages, which we totally won't do because we are running on a virtual machine with 2 gigabytes of memory, but in theory, this thing would define, I think, 9,000 builds or so. Right, and obviously you can go all out and say build all of Nix packages. Right, so every build that is supposed to run on one of those platforms that you define as supported will be scheduled and will have a job created for it. Yeah, that's up here. Yeah, exactly. This is an argument that you have to pass when you import this release lib. This release lib is pretty useful, but it's really useful if you're building things in the context of Nix packages. If you're building your entirely own kind of stuff and you don't use Nix packages, then it won't be so helpful. This Hydra job function is actually exists in the lib hierarchy, lib customization.nix or something. Okay, so this is how package sets are created. Here package sets are run, and then, yeah, you have essentially what Hydra NixOS org does, but running in a virtual machine now. So,
Anybody figured out what that channel thing does?
oh,
How do you get a channel there? I don't know.
yeah, the job set has to define a channels attribute, and then there must be something must be defined in there, but I don't know for sure. I mean, it used to be, I think it used to be fully, this always works, right? So if you go to job set, channel, this is the channel that you always get. This is generated by Hydra.
Yeah.
So you can subscribe to this using this URL, and then you'll have all the builds existing on this particular job set as a binary cache available. What you don't have is you don't get any build expressions in here. This is just information about I have this many builds and they have this hash and this path. This is all the information in here. Right, so this exists automatically for everything, but you can also define your own channel which adds information or strips information or whatever you want to do with it. So then let's check that the signature things I promised actually works. So we take, for instance, this path, and now how does this work? This is the Hydra. So this is what Nix does when it tries to download some build expression, right? It knows the hash, then it asks the server, and here you see the important part, right? It's actually signed. So that actually worked. I have another job set. I think this one is interesting because it will actually compile something. There is no binary substitution for that one, because that's job set, enable, lib fastcgi.nix. No emails. What's this called? fastcgi source. That should do it.
It would be nicer if this configuration was in Nix.
Yeah.
Not
Yeah.
in that way.
Yeah, or at least if there would be some kind of command line tool that abstracts this database layer away, right? But it's not there, unfortunately.
Which one?
Well, all this information about the job sets and the projects that you have is stored in the Postgres database. And it's not easy to decide basically which part of that database you want to to save, right? Because some of the information in the database you can throw away and it doesn't matter, and other information is maybe quite important, but you don't know. It's only Elko knows. So it would be nice if you had a command line tool that basically gives you the ability to create a job set with certain parameters, right? And you can run it and it will talk to the database and make sure everything works out. But nothing like that. It's the web interface. Here we have something happening. So this is the first time that we actually compile something, and we compile that on the exactly. So it substituted all the binary packages from. It's already finished? No. Oh, it's already done. Too quick. But here we see one step. It had one compile step. Latest builds. There it is. So now we have continuous integration for this library, and the reason why I wanted to show that is because this is also another feature of Nix packages. It gives you these support functions. One of them is called source tarball, and that's a very easy way to create to have a Git repository and make a distribution archive out of that. So it assumes that you use GNU automake and autoconf and that stuff. And then it basically runs disk check and creates this release tarball and makes that available. And then you run all those builds using the release tarball as a source. And this is important because suppose that you have code in your repository that depends on certain files, and you have those files in the Git repository, but you haven't actually included them in the release tarball. Then all your CI will always work because it's running in the Git checkout and all the files are there, but when you release the tarball, your users can't compile it because the files are missing. So that's why when you have CI, you should compile the release archive that you're going to release, right? That's the one that you should be testing. And this functions make it very easy to provide this kind of abstraction. So when we look inside of this job, then you see that there are actually two jobs: the tarball, which is the job that just generates this release archive, and then there is the actual build, which uses this tarball as input. And this is what this stuff looks like. And here again, here we can't use this map test on abstraction because this package is not a part of Nix packages. So Nix doesn't have it. That's why we have to do this thing explicitly. Yeah?
You said that the source tarball function only works on AutoTools packages.
Yeah.
But is there a way to customize it, like with build recipes within Nix?
Very little. There is very little ability for customization. I think it's how's it called? Source release. I think this one is it. Source tarball. And then you see that there is basically no hooks or very little hooks. There is no way to, for instance, originally I wanted to build the GNU Hello World, since that's the one we built from Nix packages. I thought, yeah, let's run CI on their repository. And then it turns out that the bootstrap script that they have, it needs special options passed to tell it, don't access the network. Because when you run the bootstrap script without any options, the first thing it does is that it tries to download the latest versions of I don't know what kind of libraries, right? And so I wanted to pass this option to tell it don't do that. And there is just no way, right? I can't add any options in here. And so it turned out that I really can't use this nice, so I wanted to demonstrate how nice and convenient this function is. It just happened to be super not nice and inconvenient. So I said, yeah, man, then let's use a different library.
You can take it and replace the autoconf.
Yeah, I suppose you can, right? But you could also, I mean, this stuff it's open source, right? You can add all kinds of, you can add something like bootstraps, parameters, make it a function argument at the top, there you go, right? It's easy enough to do it. It's just in its current state, this stuff is very much geared at automake and simple automake projects. And these builds are super simple, right? There's all automake, and this means that Nix doesn't need to know anything except the required build inputs, and that's it. And this is obviously now we can add other systems, and this is a fairly sophisticated continuous integration setup that you can define with a couple of lines.
I guess for projects like you have smaller ones, or which are more like libraries, like Haskell libraries, you
Yeah.
just need the Git checkout, more or less, right?
Yeah, they have the same problem though. You want to build from a release archive and not from the Git checkout.
I know. So there is also some bootstrapping there?
Yeah, for Haskell we have there is our own function. That would be the next thing, because it would be really weird if I didn't talk about how to build Haskell. And here we have our own support functions for that, because the normal ones just don't work. So in this case, this is a build that's generated by Cabal to Nix. This stuff is auto-generated, right? The only thing that I edited is the source and the version number, because these come from here. So this argument is passed by Hydra. And then everything else is just the normal Haskell build stuff. And then the interesting thing is this part. And here we use this matrix thing with this. We generate attributes over 2 dimensions. First of all, we generate an attribute set for every supported system. And secondly, we generate an attribute set for every supported compiler. So in this case, we have up here a list of supported compilers. And with Nix packages right now has something like 75 different package set configurations. So if you wanted to, you could add them all to the list up there, and you would have 75 times 3 or something builds for every commit.
What is the output of compiling a Haskell package?
You get the actual binaries out of this. This is
This program.
yeah, absolutely, yeah.
Not a
No tarball.
not a library.
No.
Object.
This the release tarball is kind of hidden in here. We run this build with, or do we? No, I actually don't. There is a function. There is in the Haskell library. There is a function which is called like build package strictly or something like that, and you add that in front of the derivation, and then it will compile first of all the release tarball, then extract the tarball, remove everything else, start compilation over again. So it does this thing that we have here in 2 steps. It does that in 1 step, which is not as nice as this, but it gets the job done. But it turns out I didn't even use this here. So I think what this just demonstrates is how you can easily generate builds, a whole matrix of builds, right? I have the build instructions are here, these are automatically generated, and then I specify my list of hardware platforms, my list of compilers at the top, and I get hundreds of builds out of it. And Hydra runs them all, and you get an email when something doesn't work. And I think that you could probably make this even shorter and even nicer if you factor out a couple of functions that you reuse, right? But you would have a hard time duplicating this expressiveness on Travis CI, right? Because this can
generate.
It would be hard. Yeah, you could probably generate the YAML file, but this thing can indeed run for 3 architectures and some 70 package sets the builds, and that's quite nice. I actually tried doing that in the VirtualBox virtualized hardware, and then the machine was gone. So that's a job set that you should not run in the virtualized thing, because GHC is just freaking expensive when you compile with it, and they don't have enough memory for that. So I've never used Hydra for releases. I just use it for continuous integration essentially. But yeah, I mean, there is lots of stuff that I have no idea about. There is this whole business of how do you create channels that contain expressions as well as binary cache information. There are all kinds of crazy features in Nix in Hydra that I have never used and I'm totally unaware of. I think that if you're on the IRC channel, then there is Aslik.
Yeah.
I think he's probably the most sophisticated Hydra user, save Elko, right? He's running a very sophisticated setup and also contributed to the code, so he's the one to ask, I guess, and Elko also answers questions every now and then. So finally, in the README, this is something that's might be important to know if you run your own Hydra server and you run out of disk space, and this happens frequently, unfortunately, then it may be that you start the garbage collection service and it doesn't do anything. And the reason is because you've configured something like the last 10 evaluations are supposed to be kept. Now, once a day, there runs this update GC root service, and this throws away the references to all the evaluations that are no longer supposed to be kept. But this runs only once a day. So what can happen is that this thing ran 23 hours ago. In the meantime, you had 500 evaluations, each of them produced binaries, and you could throw away 495 of them, but Nix doesn't know about it. So you need to run this job, which is real quick, takes a minute or two at most, and this throws away all the references to evaluations that no longer need to be kept, and then the garbage collector can collect them. But it happened to me a couple of times that I wanted to make space and I run the garbage collector and it says I can't collect anything. And then that's because this thing needs to run. So that's useful to know. All right, so that took much longer than I thought, but I hope it was interesting and informative. Do you have any questions?
I have lots of evaluation errors.
Yeah.
They always say something like lambda, unknown something lambda. I think it's trying to walk the attributes or something, and it doesn't know how to walk the lambda. But I'm not sure how it got there and what to do about it. Everything works. It just gives this warning.
Evaluation errors are unfortunately fairly common in Nix packages. This code that automatically discovers all builds and schedules them, that will not produce those. So if you have these evaluation errors, then it's because your job set contains an explicit build somewhere. It says build this thing, and then the thing that you want to be built is not a derivation, but it's actually a function. And then Nix will say something like lambda, I don't know, can't be evaluated or so, because it's expecting a build, but it's getting a function that maybe produce a build, but you give it a function and not a build.
But it still does the thing.
It does. Even though if you have an evaluation error, then it can't.
I think it's a warning or something.
The evaluations typically contain an attribute. So we can go to NixOS org. So there are plenty of evaluation errors. No lambda. Right? I mean, in any case, the first line should always be this, right? And this gives you the exact attribute from your job set that triggers right? While evaluating this attribute, this error occurred. And so this is the definition that's not correct. And this recursive detecting of packages won't evaluate anything that is not a package.
And this evaluation that happens only to find out what to build, or
yeah. So it computes the store path for every expression in your job set, and if it's new, builds it.
Substitute.
Yeah. So there are all kinds of reasons why you get these evaluation errors, right? The most common one is that some package is broken and it's marked as broken. So when the Hydra goes through the job set, it sees this package is broken, so I won't build it. Fine. Then it tries to build another package which depends on the broken one. And in this case, you get an evaluation error. Right? Because you have a build that's valid in principle, but it has broken dependencies. And technically, I think you're not supposed to do that, but I'm not sure. We probably have a couple of hundred.
100? I think it's
Maybe it's thousands, yeah. So for trunk, high evaluation errors are essentially pointless, right? There are so many that there is no way of saying you won't never know if there is one that's important or not.
I mean, like a lot, the Python ones, that anyway, can discard them because
Here's something that's important. So manage users, and here you can choose whether you want to receive an email when there is an evaluation error or not. So when you have trouble with evaluation errors, you click here, solved. Okay, so my server just spent the last 10 minutes restarting 5,000 builds. And now it's recompiling everything.
And how do you do the upgrades? You said the Hydra does the upgrades automatically
Yeah, for the database, yeah.
for the database.
Yeah, you never notice.
And when I need to switch between 14.12 and 15.9, how does the Postgres upgrade work on NixOS?
Which version of Postgres do you have?
And there's on 14.12 there was 9.2.
9.2 is fine. 9.2 is fine. You can actually keep Postgres 9.2 and it's going to work fine.
between 8 and 9 there is a, I think you need to...
Yeah, but I
convert
think that
it, you know.
Hydra is supposed to work with Postgres 9.2 or later, so you don't have to use a newer version of Postgres. You can skip that problem for now, right? You just update your system, but you keep the same version of Postgres, and then Hydra will automatically update the schema and everything will work. You'll have no problem at all. Then make a backup,
And in the future?
and then in the future, at some point, you will probably have to make a backup of your Postgres installation, and then I think there is something called PSQL update or so,
Okay.
or migrate. Man, this server is busy. I can't find it easily now, but there is something like that.
Everyone needs to install something.
Yeah, Postgres has a utility where you can basically take the new version has a utility which you can point to the old database and it will upgrade everything, and then you have a
But
new one.
inside 9 it will actually work even with old schemas. Like you can-
Yeah, I think 9.4 can just use the one from
The
9.2.
problem is between the 8 and 9. There you really had to stop, upgrade it,